So students, I have shown you that how to represent Turing machine through there are three procedures. I have shown you that instantaneous description, transition table, and transition diagram. There are three ways I have shown you. So today I am going to show you that these all whatever we have done, that is deterministic Turing machine, because in that case number of a's equals to number of b's a to the power n in b to the power n are n, where n equal greater than equals to 1. So that was number of a's and number of b's are equal. So that was deterministic we have drawn. So non-deterministic Turing machine we need to learn. So that's why today I am going to show you the non-deterministic Turing machine. So let me take the heading non-deterministic Turing machine. What is the transition in this case? It will be delta will be equals to q into rho. This basically to the power of q into rho to the power of in rho into L or R. Okay, so this is a transitional function regarding the non-deterministic Turing machine. So let there exist a transition function delta of q0 comma 0 q0 0 or maybe q1 1 r. Okay, for traversing the input symbol we have to consider true transitions and construct the Turing machine accordingly. One important thing is that the non-deterministic Turing machine is more powerful than deterministic Turing machine. So let me show you one example of this non-deterministic Turing machine. Let me take a question. What is that? Question is that construct a Turing machine over a comma b which contains a substring a b b. So let me show you the solution. So in regular expression, this can be written as comma B star, then your substring, then A B star, okay, A plus B star, okay. So in this expression the substring is very important. So the string may be ABB only, this is possible. In that case, the machine gets A as input in the beginning state, okay. But before traversing ABB, there is a chance of traverse A of A comma B star so the transitional functions are, what are they, delta of q1 comma A, q1 comma A will be q1 A or R, or maybe q2 A R, then delta of q1 comma B, q1 then B then right. The delta of q2 comma B, q3 comma B comma R, delta of q3 comma B, maybe go to the q4 B and R, delta of q4 comma A, q4 comma A comma R, delta of q4 comma R, delta of q4, it is blank, then it can go to the qf, blank symbol blank, there will be halt state, okay. So if I represent this diagrammatically, it should be looks like this. In finite automata, this is in q1 state, we are reading a symbol A, it can go to the q1 state, it can go to the q2, then By reading B, it can go to the Q3, then it can go to the Q4, and in Q4 there may be A comma B. Here also A comma B, because there is a AB star. Okay. So if I represent in Turing machine, how it will be looks like. So there will be QI state, then Q1, then Q2, Q3, then Q4, QH. So initially it will start with a blank R. Here it can read A comma R, B comma R, then A comma R, then B comma R, then B comma R, and Q4 there will be again and here again blank null R. So this is the representation of Turing machine. So let's see this conversion of regular expression to a Turing machine. What is the procedure? So see the procedure. A regular expression can be converted to equivalent Turing machine by the following process. What are the process? First thing, convert the regular expression to an equivalent automata without epsilon move. I think you know what is an epsilon move. Okay. Then change both the initial state and final state of the automata to an intermediate state. Okay. See this example. There are two. This initial state. This is a final state. Okay, so for this conversion to the Turing machine, what the thing you have to do, there are two intermediate state has been drawn. This is a initial state, you can see, and in the final there you can see another intermediate state has been drawn according to the step 2. Now in step 3, what is it written? Insert a new initial state with a transition function blank R. Okay. To the automata's initial state. So you can see here also blank R is given, and afterwards what was the automata, it is same as it is in the final state. Also this is given blank R, and this is the QH, means whole state. So this is the intermediate state has been drawn. So this transition you have to give as per the third process. In the fourth, what is reason? Convert the transitions with the label input to IP, means input to IPR. So it is already written. See this IPR means this, it transition is written A, so it is written AAR, input R, AAR. That's why in the fourth step it is mentioned, just see AAR. Okay, so its transition was A, so AAR. Same way for each and every transition, you have to mention the input as a input, then your move. Input, then your move. Okay. And in the fifth state, insert a new final state with a transition blank R from the automata's final state to the new final state. So already you have inserted this in this diagram. You can see that QH by this particular blank R is a move transition we have given. So this we have to do as per the process fifth. So what was the example? Question was that construct a Turing machine for the regular expression a plus b star into AA plus BB into A plus B whole star. Okay. So for that, what I did, see the finite automata accepting the regular language is, this is the finite automata. You can see in Q0 A plus B star means AB loop is there. So this is the finite automata we have drawn without epsilon move. Already you had this mentioned, and this is non-deterministic finite automata because by giving A or B we can go to the Q1 as well as Q2 as well as in Q0 also. So this is non-deterministic. So insert a new initial state Qy and final state QH. The finite automata will become, looks like this. What is that? Qy and QH I have inserted, and initial the automata is intact over here. Okay. Now finally what we have to do as per the rule 5, that rule 4 and 5, what we have to do? We have to convert the each and input symbol by the input and transition and move. So you can see that blank R is already there. So for this AB, this will be AAR, and for this BBR for B. For A it is AAR, for B it is BBR. Same way over here also AAR, BBR, and in Q3 it was AB's loop was there, so it is AAR and BBR. And for this final state we have to give a blank and your right hand side move, so R. So this is the conversion of this regular expression to the Turing machine. I think you have understood how to write down the non-deterministic, how to draw the non-deterministic Turing machine by this particular process. Thank you.